afternoon, students. In this video, I'll be taking up the topic of some applications of trigonometry. As for grade 10th is concerned, you have two topics based on trigonometry. One is Introduction to Trigonometry and one is Applications of Trigonometry. These two topics have a total weightage of 12 marks as per CBSE board examinations concerned. So, as for Applications of Trigonometry is concerned, you usually get a 3-mark sum. You have already done in trigonometry different T ratios of specific angles, T ratios of complementary angles, and you have already studied different trigonometric identities. Now what we are going to learn in this topic, we are going to make use of the knowledge that you have learned in trigonometry that's going to be applied to this topic, some applications of trigonometry. Let's first get an overview of what trigonometry is all about. As your teachers have taught you, trigonometry is an offshoot of geometry. It's a branch of mathematics. As per the name goes, trigonometry, it has been derived from two Greek words, trigon and metron. It's all related with triangle measurement. Means you have a situation in which you have a triangle, and in that triangle, some of the sides and some of the angles are given. See, we know that if you have any triangle, not necessarily that this has to be a right angle triangle, as the most common notion is that trigonometry is only used in a right angle triangle. No, the case is not like that. If you have any triangle, you have three angles which we denote by capital letters, and you have three sides. Three sides we denote by small letters. Now this side, it's opposite to angle A. I will denote this side by small letter A. This side is opposite to angle B, AC. It will be denoted by letter B. And this side is opposite to angle C. It's being denoted by letter C. Now you have three sides and three angles in a triangle. Total they sum up to 6 elements. Small a, small b, small c, they denote the sides. And capital A, capital B, capital C, they denote the angles. Now total these are 6 and we call them as elements, or you could say parameters of a triangle. Now in a particular situation, some of the sides and some of the angles will be given, and you are expected to find the remaining elements, means the remaining sides and angles. That is the job of trigonometry. So wherever you have a situation, you make use of trigonometry. Now, how does trigonometry achieve this? Trigonometry has two important tools. One is the Pythagorean theorem, which you have already done in lower classes. These are tools of trigonometry. One is the Pythagorean theorem, or you call it as Pythagoras theorem. And the next one is T ratios, which you have already done in some this introduction to trigonometry, T ratios and Pythagorean theorem. But Pythagorean theorem and T ratios both are applicable, both are applied, both are valid in a right angle triangle. So these tools are being used in trigonometry to find the sides and angles of a particular triangle. Now there are many applications of trigonometry, and we are asked to move to some applications of trigonometry. Let me try to list some of the applications of trigonometry. Trigonometry is widely used, and we say it's almost used in all spheres of human activity. It's used in navigation, it's used in surveying, it's used in map making, it's used in construction work. It has also wider applications in science of seismology that deals with earthquakes. It's also used widely in physics, like in order to find the nature of an atom. It's also used to design electric circuits. It's also used in estimating the height of ocean tides. We also use it in music, like to analyze the musical notes. And last but not least, it's used to find the heights and distances of inaccessible objects. That is the case. We'll be asked to find the heights and distances of inaccessible objects. Let's see how this is related in daily life. Let me take a typical example. For example, you are in a garden and you just witness there's a beautiful tree, palm tree. You get an idea, how could I find the height of this tree without taking the pain of climbing the tree? So that is the job of trigonometry. Trigonometry will help you to estimate the height of that tree. Or one more typical example, like you are on one side of a river bank, and you get an idea, how could I calculate, how could I find the width of this particular river without crossing the river? There also you could make use of trigonometry. Or there is an object, there is an inaccessible object like a tree, like a tower, like a tall building, like a plane at an instant. so it's inaccessible to you. In all those situations, to find the height and distance of inaccessible objects, we make use of trigonometry. So we'll be doing this exercise as per your textbook is concerned. This exercise 9.1, chapter number 9. You expect a 3-mark. Sum is always asked in CBSE board examination. Let's try to see how the trigonometry could be applied in different sums. Now, we have a first sum of this exercise. It says there's a circus artist that is climbing a 20-meter rope. Now, see, for all these sums, you will have word problems. You will have situation sums. You need to frame them. You need to form them. You need to express them in mathematical terms. When you express them in mathematical terms, you get a diagram. You get a triangle. A triangle, a right triangle, one right triangle. Sometimes you get 2 right triangles. In those right triangles, one angle and one side will be always given to you. One angle, and that angle has to be the acute angle, and one side will be given. And you are asked to find the remaining sides of the triangle. Now, this chapter is sometimes also known as heights and distances. There's other name to this chapter. It's also known as heights and distances. Let me tell you why this name heights and distances. If we try to find out what we mean by height and distance, they are almost same. Both are lengths. Height is the distance between 2 points in the vertical plane. Whenever you have a vertical plane, you take 2 points in the vertical plane. Distance between those 2 points is known as height. And distance between 2 points in the horizontal plane is known as length. So they are basically distances between 2 points, be it in the horizontal plane, be it in the vertical plane. Now, question goes like this. You have a circus artist is climbing a 20-meter long rope. Now, how we frame it? This being the rope, so this would be the horizontal plane, and this is perpendicular. So you got a triangle. Now, what's given? You are given a rope that is 20-meter long, which is tightly stretched and tied from the top of a vertical pole to the ground. So this has to be the pole, vertical pole. Now, if this is a pole, so it would be perpendicular to the base. Usually these buildings or these objects, they are perpendicular to the base. Now, this pole is perpendicular to the base, and length of the rope, that is 20 meters. So I could take this as A, this as B, this as C. If BC is the height of the pole, which you have to find, AC is the rope whose length is given, but it's given that this rope makes an angle of 30 degrees with the base. So this angle is given to be 30 degrees. So AB is the distance between the foot of the pole and the other end of the rope. Now imagine you have a right angle triangle in which I said one angle and one side is always given. And you are asked to find the remaining side. Now what you will do, you have to find BC. It's a case of T ratios. Tell me which T ratio you will use. You will be using that T ratio which involves these two sides. My dear friends, this is your opposite, or you call it as perpendicular, and this is your hypotenuse. Don't forget the T ratios. I should be briefly writing them. Your sine of theta, let's recollect, sine of theta is perpendicular by hypotenuse. Your cos of theta is base by hypotenuse. Then your tan of theta will be perpendicular by base. Then comes the remaining 3 T ratios, which are reciprocals of these 3. Now, which appropriate T ratio is to be used? You are in search of the perpendicular, and the hypotenuse is given, so it's a case of sine of theta. Now, what you write when you write the response in the examination, do just write it this way. You would say in the figure, AC is the length of the rope. AC is the length of the rope, which is equal to 20 meters. Let BC be the length, be the height of the tower, of the pole. Be the height of the pole. An angle A or angle CAB is given to be 30 degrees. Just given a presentation in this way, then you could say in right angle triangle ABC, I'm going to apply sine because you need to find the perpendicular. Sine of 30 is perpendicular by hypotenuse, that is AC. Sine 30, you just remember, sine 30 is 1 upon 2. 1 upon 2, BC is to be found. AC value is 20 meters. Do the cross multiplication. This is going to give you 20 meters upon 2 is BC, or that would be 10 meters is BC. So the height of the pole we have calculated to be 10 meters. This angle was already given, this length was given, so you have made use of the T ratios. So you have used sine, but most of the time we'll be applying tan, because tan involves the height and the base, this distance. Okay, now we'll move on to other sum. This was quite easy. You expect this to be a 2-mark sum. We'll move on to one more sum. Now, second question is based like this. You have a tree. A tree breaks due to storm, and the broken part bends to that so that the top of the tree touches the ground, making an angle of 30 degrees with it. So this is based on a tree. Now there's a tree. So tree breaks due to storm, but whatever part breaks that doesn't fall down, that forms an angle. So I will take this as the horizontal ground. So imagine this is tree, AB is the tree. Now there's a certain part, this part breaks, maybe here. So when this part breaks, this comes down. It's like this, BC. This is the broken part. So this plus this is tree. Let me call this as A. I will take now here. Okay. A tree breaks due to storm, and the broken part breaks, and the broken part bends. Sorry, it bends so that the top of the tree touches the ground, making an angle of 30 degrees with it. So this angle is given to be 30 degrees. The distance between the foot of the tree to the point where the top of the tree touches is 8 meters. Now this distance is given to be 8 meters. Now this is the point where the top of the tree touches, and distance between this point and this point is given to be 8 meters. Now you are asked to find the height of the tree. So simply you have a right angle triangle in which one angle and one side is given. If I bring this distance AC back, so AC plus AB will be the height of the tree. That means we need to find both these distances, this distance AC as well as AB. So we can use, if I have to find AC first, or if you say no, I have to find AB, whatever it's, we have to find both the lengths. Let me try to find AC first. So which T ratio I'm going to use? See, AC I have to find, it's a question mark for me. So base and height, base and hypotenuse. So we'll be making use of cos of 30. So in a right angle triangle, just make it a point in the beginning, just give an introduction, say AB plus AC is the height of the tree, angle C is 30, BC length is 8. That you should make a habit of writing. Now here I will just write directly. In right angle triangle CBA, cos of 30 is BC by AC. Cos 30 is root 3 by 2. Mind it, cos 30 is same as sin 60. It's root 3 by 2. Equal to BC is given to be 8 meters and AC as it is. Do the cross multiplication. So root 3 into AC will be 8 into 2 meters. That means that is 16. So AC is 16 upon square root 3 meters. That is AC length. You could rationalize it also. Let's keep it in the time being this way. So this is equation 1. So I found height AC. Since you are asked to find the height of the tree, that means I am in need of AB. Now AC is already given to you. You have to find AB. You can make use of Pythagoras theorem because two sides are already given to you. Or if you don't want to use that, you could directly go to the T ratios. You will make use of tan of 30 because using tan you could find this height. So that means in right angle triangle ABC, tan of 30 degrees is AB upon BC. Tan 30 is 1 upon square root 3 is equal to AB. I have to find by BC is 8. So that means this gives you AB is equal to 8 by square root 3. So I have retained square root both in the denominator so that I could take the LCM. This is 8 by root 3 meters, equation 2. Now to find the height of the tree, as it's being asked, height of the tree is AB, which is the unbroken part, plus AC, which is the broken part. When you sum it up, that gives you the height of the tree. So height of the tree would be, height of the tree is AC plus AB. AC is 16 by square root 3 plus 8 by square root 3. 16 plus 8 is 24 by square root 3. You can't leave it this way. It's better to rationalize it. We'll multiply numerator and denominator by square root 3. Root 3 will be 3. 24 by 3 will be 8. So 8 square root 3 meters is the height of the tree. 24 by 3 is 8. 8 root 3. Sometimes the value of square root 3 is given, which is 1.73. You can put in the value and do the multiplication. That would be 8 into square root 3, 8 into 1.73. In examinations, you will wonder, should I leave it this way or I should do the multiplication also. If time permits you, you could put the value and do the calculation. Otherwise, you could leave it this way. Marks won't be deducted for that. So this was one more case, see, wherein you had one triangle. Because we have sometimes more than one triangle. Sometimes you have two triangles and sometimes three triangles also. But the concept is same, that whatever the right triangle is given, in that triangle, one angle and one side is always given, and you are asked to find the remaining sides. So this was based on what we did. Now we'll be moving on further. Let's take one more sum. See, there are other questions also which are of the same format, but I would like to take a question wherein you have the concept of angle of elevation as well as angle of depression. The meaning sums are almost same, and we will be having situations in which angle of elevation is given, angle of depression is given, and two triangles are given. Before going into that, we will have a fair idea about what's angle of elevation as well as angle of depression. See, angle of elevation as well as angle of depression, both of them are angles. And you know that in an angle, you have two rays. Basically, angle is a figure which is formed by two rays. We say it's the intersection of two rays. They have a common initial point. OA and OB is your angle. Now, if the angle goes in the anti-clockwise direction like this, so then OA is my initial arm. This is my initial arm. This is my terminal arm. If the angle is going in the anti-clockwise direction, it could go in the clockwise direction also. In that case, the sign of the angle is minus. In this case, it's positive. So I could call this as theta. This would be positive. So this being the initial arm, there's a shift. OA got shifted to OB with O fixed, right? So initial arm, and this is the final arm, or you can call it as terminal arm. This is initial arm, and this is terminal arm. Now, what about angle of elevation? See, when there's an object for which you have to find, or you are watching an object, you want to find its height, or you want to see how far that object is from you. In that case, you are the observer, and there's an object. For example, I'm just looking at the ceiling. Ceiling is the object for me. I'm the observer, and the process is going on. That's known as observation. So when you see an object, that object can be at your eye level, or it could be below your eye level, or it could be above your eye level. What does that mean? See, we have one term that's known as line of sight. Line of sight is the line joining your eye and the object that you are going to watch. See, light travels in a straight line. If I'm watching an object, if I'm seeing an object which is at my eye level, So the line, it's an imaginary line joining the eye to the object. So we express it this way. If this is the eye, this is the horizontal line. This is basically line of sight. It's also known as horizontal plane of eye. Now the object that you are going to view, it can be above the horizontal plane, this horizontal line, it could be below. Imagine there is an object that is above this horizontal line. Imagine you are watching a kite. So to see the kite, I have to shift my eyes, because in the initial position, my line is like this, it's parallel to the base. So I need to shift my eyes. When I shift my eyes, the line of sight got shifted. That means OA was the initial position of the line of sight. To watch the kite, I shifted this line of sight to have a view of the object. It got shifted to B. Previously it was OA, now it's OB. Now this is angle of elevation, I could denote it by angle E. In short, angle of elevation is the angle which is formed at the eye of the observer. When the observer is observing an object which is above his or higher level of eye. To view a plane, to view a kite flying or a bird flying, angle of elevation will be formed at the eye of the observer. Same applies to angle of depression. Depression going down, elevation going up. Angle of depression would be when I watch an object, when I see an object, when I view an object which is below my level of eyes. For example, I have to see something on the floor. So I will shift this horizontal plane, horizontal imaginary line, it got shifted. So angle of depression will be formed at the eye of the observer. Now, there will be some questions in which the height of the observer is not given, and sometimes the height of the observer is given. Usually the height is being ignored, because the height of the observer, usually it could be 1, 1.5, 1.6 meters, 2 meters is almost 6 feet. That height is being ignored in comparison to the height of the object, for which you are going to estimate its height or the distance, how far that object is from the observer. So I'm going to take a question in which the height of the observer is given and angle of elevation is also given. That is question 6 of this exercise. This is question number 6 of your NCERT textbook. It says a 1.5 meter tall boy is standing at some distance from a 30 meter tall building. You need to read between the lines. See, you have a tall, 30 meter tall building. So 30 meter tall building, what I will do, I'll draw this building, construct like this. So imagine this is building, and there's an object. There's an observer. This is boy. His height is 1.5 meter tall. Boy is standing at some distance from a 30 meter tall building. Now this building is 30 meter tall. So this is 30 meter tall. Let's take AB, it's perpendicular to the base, this is the building. Now this is the observer, CD. How much is his height? 1.5 meter tall. Okay. The angle of elevation from his eyes to the top of the building increases from 30 to 60 as he walks towards the building. Now what's the angle of elevation? In the beginning it was 30, then the boy, the observer, is moving further towards the object, angle of elevation increases. As you go towards the object, angle of elevation increases. It increases from 30 to 60. Now, first I have to draw the horizontal line, this line. So this angle is 30, this being the eye of the observer. Now the observer is moving some distance. Imagine he reaches point E. Now here he observes, now angle of elevation increases, it goes double, it's 60. So let me take this as M. Now this is your diagram. What we are asked to find? We are asked to find the distance he walked towards the building. Now this is the distance walked. Let me denote it by X. This is the distance walked. This distance. This or this, it's one the same because it's a rectangle. So in your diagram, you have two right triangles. this figure being a rectangle, if this is 1.5, this is also 1.5, this is also 1.5. Now you need to enter the right triangle. Which is your right triangle? My right triangle is ASE, and one more right triangle is ASD. Now in that right triangle, both of these right triangles, the acute angles are given. This is also 90. And what about this height? This total is 30. This is 1.5 because this person, he maintains his height. This is 1.5 here. When he walks towards the object, height remains same. And if he goes here, height will be also same. So I need to find AS. So AB is given to be 30 meters. SB is same as 1.5 because this height, and this height is same. So you need to find AS, that is the height of the right triangle. So AS will be AB minus SB, this height of this right triangle. So AS will be AB is 30 minus 1.5, that is 28.5 meters. Now you need to find this distance, how much he has walked. Boy is walking in this direction towards the object. Now this distance is same as this distance. You have two right triangles, so you need to enter both of the right triangles. Now we will enter triangle ASD. Which T ratio I should use? Should I use sine? No. Should I use cos? No. Why shouldn't you use sine and cos? Because sine and cos, my dear friends, it involves hypotenuse. You don't need hypotenuse. You are concerned with this length, rather this length. If you go to the big triangle and make use of tan, you get this base. Tan is perpendicular base. In the big triangle, you will get this distance. In the small triangle, you will take this distance. You will get this distance. Then subtract both the distances. That's going to give you distance DE, the distance that the boy has walked. So we will enter both the right triangles. Now, which right triangle? The smaller one or the bigger one? It's one and the same. Doesn't matter. So I will move on to, in right angle triangle, ASD. Make use of tan. Tan of 30 is perpendicular. That is 30 upon base. Base is ds. How much is tan 30? It's 1 upon square root 3. That is 30 meters upon ds. So ds will be 30 square root 3 meters. So your ds is 30 root 3 meters. No need to give the value for root of 3. Now let me move on to triangle ASE. In right angle triangle ASE. Again apply tan. Tan of 60 degrees is perpendicular upon base, that is AS upon, which is 30. I should write the value direct. No, sorry, it's not 30. It is 28.5. Because it was 28.5. See, AS is 28.5. This is not 30, this is 28.5. 28.5. Because we have calculated AS, that was 30 minus 1.5. So this distance is 28.5. 28.5. Okay. Now in right angle triangle ASC, tan 60 is perpendicular, again 28.5 by base. Base is ES. How much is tan 60? It's square root 3. Tan 60 square root 3 is 28.5, in fact meters, 28.5 upon ES. So cross multiply, it would be ES is equal to 28.5 upon square root 3. Right? Now we need to rationalize this. This is square root 3 by square root 3. That will be 28.5 upon 3 into square root 3. We didn't have a square root in the denominator. I left it that way. So 28.5 upon square root 3, do the rationalization. So that will be 3. It will be 3 9s 27, 3 5s 15, 9.5 root 3. 9.5 root 3, 3 9s 27, right. Now this is my ES. Now what is the distance traveled? Distance traveled by the boy is DE, distance traveled. Distance traveled is DE. And what is DE? DE is DS minus ES, isn't it? DE is DS distance minus ES. How much is DE? How much is DS? 28.5 square root 3 minus ES. That's 9.5 root 3. So that would be 19. 18 minus 9, 9. 1, 19.0 square root 3 meters. That is 19 root 3 meters. Or if you need to multiply the value of root 3, that would be 1.73. Multiply that with 19. So 19 root 3 is the distance. If you need to multiply, see, we could do it 19 into 1.73, do the multiplication, and whatever answer we get, that is the distance that the boy has traveled towards the building, this tall building, which was already 30 meters high. So what we did in this question, we applied the concept of angle of elevation, and we had two right triangles, but whatever you do in one right triangle, same is to be done in two right triangles. Sometimes you have three, but this book has maximum questions wherein you have two right triangles. So it's immaterial which triangle you will go, which triangle you will enter, the smaller one or the bigger one, depending on the magnitude of the angle. So now let's try to move on to a question wherein you have angle of depression, and sometimes you have sums in which you have angle of elevation as well as angle of depression. Okay, we'll move on to one more sum. This sum is worth 3 marks. Usually you get it in section C. We are mostly making use of tan. Do remember tan of 30. These values you have to remember. You have done in the previous class. It's 1 by square root 3. And tan of 45 is 1. And tan of 60 is square root 3. Mostly tan will be used. Okay. One more sum wherein you have again angle of elevation, but something different. Different in the sense that you have a pedestal. On top of that you have a statue whose height is the pedestal is something like this. This is a pedestal. On top of that you have a statue whose height is 1.6 meter tall. Okay. So what we'll do, we'll draw this being the statue. Okay, let me draw it a little bit bigger. Now let me take this as the pedestal. This is pedestal height A. A little bit bigger. A, B, this is pedestal, and AB is the statue. So this is perpendicular, this is horizontal plane. Now you have a statue 1.6 meter tall. Height of the statue is already given. So this height is already given to be 1.6 meter tall statue that stands on the top of a pedestal. Now from a point on the ground, the angle of elevation of the top of the statue is 60, and from the same point the angle of elevation of the top of the pedestal. So from this point you are seeing the top of the statue, and from the same point the top of the pedestal. Top of the pedestal means foot of the statue. So two angles being formed at the same point. This is point C. Let's take this as D. So from the same point you see the top of the statue and you see the top of the pedestal. Angle of elevations are 60 and 45. So the larger of the angles is 60 degrees and the smaller of the angle is 45 degrees. Now what are we asked to find? We are asked to find the height of the pedestal. Height of the pedestal will be BC. My dear friends, again you have two right triangles, but they have the same base DC. You have right triangle DCA as well as right angle triangle DCB. So we'll go in both the right triangles and see how we are going to calculate the height of the pedestal, that is BC. So do write it in figure. ABC is a right angle triangle. That you should make a habit of writing in the beginning, just an introduction part, that ABC is a right angle, ABD is a right angle triangle in which angle ADC is 60 and BCD is also a right angle triangle in which angle BDC is 45, AB is 1.6. We need to find BC. Now what's the job? To enter in the two right triangles and see which T ratio you are going to use. Again you are going to use tan, because tan was perpendicular base. This base is common in both the right triangles. This being your question number 8 of the NCERT textbook. So we'll go in right angle triangle ACD. What should I apply? I should apply tan. So tan of 60 is perpendicular. How much is perpendicular? That is AC upon base is DC. In the big triangle ACD, tan is perpendicular upon base. How much is tan 60? That's square root 3. How much is AC? Just observe, it's 1.6 meters plus BC, which you have to find. You could denote that by H, the height of the pedestal. For convenience sake, let me denote it by H, because my dear friends, your AC is 1.6 plus H, 1.6 plus BC. Okay, I replace that. How much is DC? DC is as it is. So I could take the value of DC, 1.6 plus H upon root 3. I found the value of DC. You will say, why you calculated DC? Because this DC, I do need it in the next triangle. So we are going to eliminate DC so that we get the value of H. Now we'll move on to the other right triangle. In the right angle triangle, the other one is BCD. And you have tan, again, tan of 45 degrees is perpendicular, in this case is H upon base is DC. But tan 45, as you remember, it's 1 is H upon DC, that means DC is H. Now what do you want? Do you want DC or H? We want the height. So what we do, if this is equation 1, this is equation 2, from equation 2, put the value of DC in first. Put value from 2 in first so that you get an equation in terms of H and solve it. That means from 1, what we have from 1, DC. DC is H. H is equal to 1.6 meters plus H upon square root 3. You replace this DC by H. So you got an equation, single equation in terms of a single variable, that is H. Now solve this to get the value of H, and that's the answer. Cross multiply. This will be H square root 3 is 1.6 meters plus H. So it has to be H root 3 minus H equal to 1.6 meters. Take H common, that will be root 3 minus 1 equal to 1.6 meters. So I don't have place here. What I will do, I will take it a little bit here. So my dear friends, H is going to be 1.6 meters upon square root 3 minus 1. Dividing both sides by root 3 minus 1. You can put root 3 value as 1.73 minus 1, then you will have a decimal. It's better to rationalize it. That means we'll multiply it by root 3 plus 1. Same here, root 3 plus 1. So H is going to be 1.6 into root 3 plus 1. What about in the denominator? Famous identity. A minus B into A plus B. That's A square minus B square. A minus B into A plus B will be A square. What is A square? 3 minus B square. That's 1. So H will be 1.6 into root 3 plus 1. 3 minus 1 is 2. So it will be 1.6 upon 2 is 0.8 into root 3 plus 1, so many meters. Put the value for root 3, 1.73 plus 1, that is 2.73, multiply by 0.8, that is your value of h in meters, right? Sometimes if they ask you to find the height in kilometers, so you need to change meters to kilometers. Now we'll move on to one more sum. We haven't yet come across a question in which you have angle of a depression. Let me see if there's a sum. There has to be a sum where you have angle of elevation as well as depression. Ninth also has angle of elevation. Yeah, there's a sum in which you have angle of elevation as well as angle of depression. That is question number 12. Right. So let me take this question 12, so that because in angle of depression you are making use of alternate angles. So let's try to move on to question number 12, in which you have angle of depression. Before 11, sorry, I'm not able to get a question in which you have angle of depression. Okay, that is question number 12. So we need to rub this part. If you are comfortable with expressing this word problem, this statement sum, in the form of a diagram, things will be much easier for you. Because once you make a diagram, things are clear for you. You have to enter the triangle and make use of the t ratio, which is most of the time tan of theta. Okay, now question number 12. Question 12 says, from the top of a 7-meter high building, now, a person is on top of a building and the height of the building is 7 meters. The angle of elevation of the top of a cable tower is 60 degree and the angle of depression of its foot is 45. Try to understand. First of all, you have a building and you have a cable tower, which you think has to be higher. Higher is the cable tower because from the top of the building, he sees the top of the cable tower and angle of elevation is there. And obviously, this cable tower will be opposite to the building. Both of them are on the same horizontal plane. So that means this being one object, this is the horizontal ground joining their foot, and this is the other object. Now if this is the building, this is the cable tower. This has to be the cable tower. And this is the building, in short BLDG, I should write it. Okay. Now, person is on top of a building that is 7 meters high. So, this distance is already 7 meters. We can name them. A, this is perpendicular, B, this is C, and this point is D. Person is on top of the building. He sees the angle of elevation of the top of the cable tower is 60. Now, from this point, A is to be observed. Now, this angle is 60 degrees. Person is at the top of the building, watching the top of the cable tower. Angle of elevation is 60. Call this point as M. And the angle of depression from the same point of the foot is 45. Means from the same point you see the top of the cable tower, and from the same point you see its foot. Angle of depression. This is the line of sight. It got shifted. Same line of sight got shifted down. Now this angle is given to be 45 degrees. Angle of depression is 45 degrees. Determine the height of the tower. You have to find the height of the tower. I could take the height of the tower to be small h. Let height of the tower be h. Okay, my dear friends. Now this is 45. Now you have a right angle triangle like AMD, in which one angle and one side is given. So what's the side? That is AM. What's the length of AM? See, this figure is a rectangle because this parallel to this parallel to this. One angle is 90. It's a rectangle or a parallelogram. So if this is 7 This also is 7 meters. This equal to this. Now what is AM length? Rather, yeah, the height you could say. AM is AB minus MB. That is H minus 7 because we have assumed AB to be H. So AM is H minus 7 meters. Okay. Now, which other triangle you will enter? You can enter this triangle also. This triangle. Since this is parallel to this, this is the transversal. If this angle is 45, this also is 45. So enter this triangle now. Previously you entered this triangle. Now enter this triangle. Both triangles, this as well as this, and they have a common base. That is DM and CB is same. So let's enter both triangles. In a right angle triangle, AMD, which T ratio I will use? Tan. Tan of 60 degrees is perpendicular upon base, that is AM upon DM. How much is tan 60? Square root 3. How much is AM, my dear friends? Just now we calculated. It's H minus 7 upon DM. So DM will be H minus 7 upon square root 3. What is DM length? DM length is same as CB length. Okay, leave this as equation 1, whatever you want. Okay, move on to the other triangle. Give a space. Now in right angle triangle DCB, use tan. Tan of 45 degrees is DC upon BC in this triangle. DC upon BC. How much tan 45? That's 1. How much is DC? That is 7 meters. How much is BC? BC as it is. So BC is 7 meters. Right? But my dear friends, BC and DM are same. Because BC is equal to DM, both BC is equal to DM, both are equal to 7 meters. Therefore, from equation 1, this is nothing, but this is 7. 7 is equal to H minus 7 by root 3. This DM is same as BC, which you calculated by entering the other right triangle. So this is 7. 7 is H minus 7 root 3. Rationalizing, not rationalizing, cross multiplication. 7 root 3 will be H minus 7, or that has to be 7 root 3 plus 7 is H. Solving it, take 7 common, root 3 plus 1 is H. We can leave it this way. No need to do the rationalization because the irrational term is in the numerator. So H is 7 times root 3 plus 1 meters. That's the height of the cable tower. Therefore, your height is H is 7 times 1 plus square root 3 or root 3 plus 1, so many meters. So that was a question in which we came across angle of elevation as well as angle of depression. Okay. See, there's a sum which is entirely different in the sense. Something related with angles is given. Let me try to do it, and after that, if time permits, we'll move on to some sums in which we have speed sums. They are very expected sums. So let me try to do this sum. This will be the 16th question of your textbook, and a relation as far as the angles is concerned. Little bit different than what we have been doing. So the angle of elevation of the top of a tower from 2 points at a distance of 4 meter and 9 meter from the base of the tower. So there's a tower whose height is not given, but you have to prove. You have to prove that the height of the tower is 6 meters. Angle of elevation of the top of the tower. So there's a tower. Let me draw this as a tower. AB is a tower whose height is not given. You are asked to prove that its height is 6 meters. The angle of elevation of the top of the tower from 2 points. Now, angle of elevation from 2 points. Now you are watching, you are viewing the top of the tower from 2 points, like this be point C, this be point D. Now from this, when you observe, you have one angle, and from this again you have one more angle from 2 different points. The distance of these 2 points is 9 and 4 respectively. Now CB will be 9 meters and this will be 4 meters respectively. And both of these 2 points, they are in line. They are in the same straight line with the foot of the tower, with the base of the tower. But what's given? What about these 2 angles of elevation? It says they are complementary. So in the previous sums, the questions that were given, the angles that were given, they were all specific angles, standard angles like 30, 45, 60. But here, both the angles are given to be complementary. Now, complementary angles, as you know, they are 2 angles that sum up to 90. Maybe this is 30, this is 60. They can't be 45 same because distances from the foot are different. And this has to be larger than this. Maybe this is 70, this is 20, this is 80, this is 10. There are n number of situations like that. Now what to do? If I take this as theta or this as theta, whatever, for example, this is theta, then this will be 90 minus theta, because the general way of representing 2 complementary angles is theta and 90 minus theta. So these 2 angles are complementary. C and D are complementary. Let angle C be theta, so D will be 90 minus theta. Or if D is theta, then C is 90 minus theta. BC distance is 9, BD distance is 4, AB distance is not given, that you have to prove, that is 6 meters. So we will go, this is question 12 of your, no sorry, it's question 16th of your NCERT textbook. Now in right angle triangle ABD, we'll be using tan. Tan of 90 minus theta is AB upon BD, perpendicular by base. And do you remember what's tan 90 minus theta? In the previous topic on introduction to trigonometry, you have made use of T ratios of complementary angles. Tan 90 minus theta is cot theta. You have done these results, so I will be applying tan 90 minus theta is cot of theta. AB, that height I have to find, BD is 4 meters. So cot of theta is AB. AB by 4, I name this first. Now we move to the other right triangle. Right angle triangle ABC. Again tan of theta is perpendicular by base. How much is base? Base is 9. Got it? So this is my equation 2. So I have to get the value of AB. So that means this theta you have to cancel. What you are going to do to these 2 equations? So that tan gets cancelled with cot. So we are going to multiply equation 1 with 2, because tan into cot is 1. Cot being its reciprocal. Cot is 1 upon tan. So what you will do? You will multiply 1 and 2. When you multiply 1 with 2, you get cot of theta into tan of theta is AB by 4 into AB by 9. This gives you 1. So you get AB square is 36, or 36 is AB square. When you take the positive square root, this gives you AB is 6 meters. That's what we were going to prove. So we'll conclude here. I hope this is going to help you as for your preparations for the CBSE board examinations are concerned. I hope you had a good time with me. Thank you.